We're going to continue to expand on parallelograms. So quadrilaterals, we've got polygons, big picture, then a little bit more specific quadrilaterals, and then even more specific than that, parallelograms. Within the parallelograms, remember we talked about the qualities that a parallelogram has. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Then we talked about a rectangle. Rectangles added right angles, which made the diagonals be congruent. So we're going to back up and take away the right angles and talk about a rhombus, and then we'll add back in the right angles and talk about what happens when you add right angles to a rhombus. Then it becomes a square. So we're going to focus on rhombi and squares today. A rhombus is not a diamond. So when you are asked what shape it is, don't say diamond. It's not a diamond. It is a rhombus. Okay, so a rhombus has the same properties all of being a parallelogram, right? Opposite sides are congruent, parallel, angles are congruent, the opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Now, here's what happens is a rhombus by definition has 4 congruent sides. Now, since all 4 sides are congruent, that causes something to happen. When all 4 sides are congruent, it causes the diagonals to be perpendicular. Okay, so when all 4 sides, that causes this to happen. All 4 sides being congruent causes those diagonals when they cross to cross at right angles. The other thing that happens is that the diagonals, not only do they bisect each other, but now they bisect the angles. Okay, so those are 3 new properties that we're going to add to a parallelogram that has 4 congruent sides, which is what a rhombus is. It has 4 congruent sides, and because of those 4 congruent sides, now your diagonals are perpendicular, and they bisect each other, and then your diagonals bisect your angles. Okay, so let's look at a couple of problems with this. As always, take your picture, always label all the pieces, and if you ever get stuck, just start filling in everything that you know. So JK is 12 and JN is 7. So I gave you sides, so if we're talking about the sides, we need to know something about all the sides, and then we're talking about the diagonals. That's the other piece of information I gave you is a part of the diagonal. So we need to focus on the rules that have to do with sides and have to do with diagonals. Okay, so keep that in mind as we're looking at this problem. In fact, let's pull these back down so we can see them. So JM, if I want to know what JM is, what I know is that a rhombus has 4 congruent sides. So if JK is 12, then I also know that all 4 sides are 12. So JM is 12. JL, that's part of the diagonal, that's a diagonal. Now what I know is that the diagonals bisect each other. So since the diagonals bisect each other, if JN is 7, that means that NL is 7. Now MN, that's a little bit different. Now the diagonals are not congruent to each other. Remember, you have to have right angles in the corners, right, to get those diagonals to be congruent. So the diagonals are not the same length, but what we do have is we do have all of these little triangles on the inside, and what we know is that the diagonals are perpendicular. So when all 4 sides are the same, all 4 of those angles in the middle are the same, which means they're all 90 degrees. Now what that creates for us is a right triangle that has a hypotenuse of 12 and a side length of 7, and I am asking for one of the other sides of the triangle. So if we go back to the last unit, that's Pythagorean theorem. So x squared plus 7 squared is equal to 12 squared. So when you go through and you do the math, you would do 12 squared minus 7 squared. You get x squared is equal to 95. If I take the square root of both sides to get x is equal to, and it'll be 9.7. So x, or mn, is 9.7. And then mk is the entire diagonal. Remember that the diagonal was bisected. It was cut in half, which means you would double that 9.7 and you get 19.4. So mk is 19.4. So it's really important. We're going to use this diagonals or perpendicular. That's really important. And the diagonals bisect the angles. Those are two that are really important about rhombuses or rhombi. So number 3, let's label our pieces. RT is 22. So I know RT is this entire diagonal. That's 22. I know that the diagonal's been cut in half, so I might just go ahead and split that in half just to have it. And then US is 18. So I'm going to go ahead and split that in half also. Let me take away this 22 to get it out of the way. So I know that this is also 9. Okay, so I know that because the diagonals are bisected, right? You might want to put that in your note. So the diagonals are bisected. So now the question is, what is VT? Well, now we know VT is 11 and UV is 9 and RS. Well, we don't know RS. Here's RS. And we don't know ST, but once we know one of them, we'll know the other. Now, this is where you got to remember, you're sitting there thinking, okay, what else about a rhombus? There's got to be something else that I know. There is. Go back and look at your rules. Remember that those diagonals are perpendicular. That gives me this right triangle right here that I can use Pythagorean theorem on. So I have 11 squared plus 9 squared is equal to x squared. So I have 81 plus 121 is 202. So 202 is x squared. And then you take the square root of both sides, and you get that x is equal to 14.2. So RS is 14.2. If RS is 14.2, all four sides are congruent on a rhombus. And so we know that ST is also 14.2. Okay, number 5, let's label our sides, label the pieces that we have. ZY is 34. While I'm here, I'm just going to go ahead and do this because I know that all the sides are the same. I may not need it later, but it's all right. I already have it there just in case. So WY is 38. That means that each of these pieces is 19. And ZXY is right here, and it is 34 degrees. Okay, so let's go and look for the pieces that it's asking for. Let's start with our segment lengths. So WZ. WZ was 34. We found that because all four sides have to be the same. VY. VY is 19 because the diagonals are bisected. So here we have congruent sides. That's why we know that. Here we have bisected diagonals, right? And then ZV. ZV, we know that the diagonals are perpendicular, which creates that right triangle. So we need this right triangle right here with this right angle. All those right angles in the middle, when all four sides are the same, all four of these angles in the middle are the same. They're all 90 degrees. 360 divided by 9 or by 4 is 90. So then I would have x squared, we'll call this x right here, plus 19 squared is equal to 34 squared. So you get a squared is equal to 795. You subtract 34 squared minus 19 squared. And then you get square root of both sides. You get that a is 28.2. So ZV would be 28.2. And ZX would be double that. The diagonals are bisected again. They're perpendicular and they're bisected. And so we know that 28.2, that would be 56.4. Now, it's going to start asking you now for the angles. So I just kind of want to take a minute. Let's go over here. Let's erase everything we've got and just look at the angle parts. So we know that angle ZXY is 34 degrees. I'm going to go ahead right now and I'm just going to fill in everything that I know. not worrying about the questions that I'm being asked. I'm just going to fill in everything that I know because I know that it's asking about the angles. Well, I know that the angles have been bisected. Okay, so if the angles are bisected, then that means that those are both 34. I know that the opposite angles are congruent because it's a parallelogram. So those are 34. So I have a couple of options of how I can go to. You might see that those are consecutive interior angles and they should add to 180. Or you might remember that the diagonals of a rhombus are perpendicular, so you might recognize that those are 90. And then I want to know the other angles. Well, if I know that angles add up to 180, right, each of these triangles adds up to 180. I've used up 90 and 34, which leaves me with 56. So each of these angles that's left is 56 degrees. So now I can go, so it's two ways. Again, you could have also taken 180 minus 68 and gotten 112 and then divided that by 2. That's another way that you could have gotten it. But I just like to always, as soon as I see a rhombus, I like to put this little square here in the middle so that I don't forget it. As soon as I know that these 4 sides are the same, I mark that these 4 angles are the same inside. So now it asks for WXZ. So WXZ is this angle right here, WXZ. So now we know that WXZ is 34. I just already had it in there. WVZ is this angle right here. It's 90 degrees. And ZYW, right there. Now we know that that's 56 degrees. And they kind of step you through these if you found them as you were looking. They kind of step you through, find the next one, find the next one. And then XYW, from X to Y to W, is this angle right here. It's also 56 degrees. Okay, so don't forget that the angles are bisected. That's a very important part of being a rhombus, is that those diagonals are bisected. Now, even more specifically, let's say, okay, what happens if it's a rhombus that has right angles? If it's a rhombus that has right angles, then it is a square. A square has the properties of everybody. Imagine you've got this waterfall coming down. It flows through quadrilaterals. It flows through parallelograms, rectangles. It flows through rhombi, and everything that it picked up as it went through all that sediment that it picked up, it dumps there at being a square. And so a square has all of the same qualities of every shape that we've talked about. So the square is the nicest one to do. So we have a square. Remember, for a square, your 4 sides are the same. All of your angles in the corners are right angles. It's a rhombus, so that means that not only are the angles in the corners, but the angles that are in the middle are right angles. It has all of those same things. The angles are bisected. Everything applies. So if AD is 11, I know that all 4 sides of these are 11. So BC is 11, AC is a diagonal. Now, you have a couple of options with AC. If you remember back when we did 45, 45, 90 triangles, then we know that this is a 45, 45, 90 triangle because those diagonals have been bisected, and each one of these is 45. Well, that means that it's 11, 11, 11 root 2. Now, you could also do Pythagorean theorem and get 11 squared plus 11 squared is equal to c squared, and you could get a decimal answer on that too. So we've got that, but it's easiest, which would be 15.6. So either one would work. BD is the other diagonal. It's also 15.6 or 11 root 2. And then EC is half of that because we know that the diagonals have been bisected, right? The diagonals are bisected. And so that is 7.8. Then we start asking for the angles. Now here's what's really nice about a square is all of the angles. That makes it really easy because we know all of these are right angles, we know all of these are right angles, and we know that all the angles are bisected. So if you bisect 90 degrees, you get 45 degrees. So DAB, that's 90 degrees. DAB is this angle right here, DAB. We've got AEB. AEB is this angle right here. It's also 90 degrees because the diagonals are perpendicular. CBD. CBD is right here. Okay, the diagonals are bisecting the angles, and that angle's 90, and I cut it in half, and I get 45. And then BAC is the same 45, because all of those have been cut in half. So every one of these angles is 45. So you get a lot of repetition with a square because they're all the same. Oh, and I just worked number 6 instead of number 7. So number 7 would be the same way. You know that TR, if TR is 17, I know that PT is 17. And since the angles are right angles, I know that the diagonals are the same. They're equal in length. So all of those are 17 also. So I know that PR would be 34. I know that QS would be 34. I know that QT would be 17 and PQ. So now I want PQ. This is where knowing that 45, 45, 90 rule would come in handy. 17, 17, 17 root 2. Or you could say that it is PQ is 24. Okay, so you can go through and use either method, but you can use Pythagorean theorem because these are right triangles. So PRS is this angle right here, which is 45 degrees. STR is 90 degrees because that's where the diagonals meet. PSR is 90 degrees because that's the corner of the square. And QPR is 45 degrees because it has been bisected. So if we look at 9, 9 is a rhombus, which means it's not a square. A square is always a rhombus, but a rhombus is not always a square. Kind of have to remember that, because a rhombus is a square only when there are right angles in the corners, but a square is always a rhombus. It always meets the qualifications to be a rhombus, but it's a little bit harder to be a square. So CDEF is a rhombus, so what we know is I'm looking at two angles. I'm looking at two angles there together, and if we go back to our rhombus rules, we know that the diagonals bisect the angles, which means these two angles have been cut in half, and that means they're equal to each other. So I take 5x plus 1 is equal to 8x minus 20. So now we solve the algebra. Minus 5x and add 20. I do it all in one step. So we have 21 is equal to 3x, or x is equal to 7. Now I asked for you to find FED. Well, FED is this whole angle right here. So that means we need to find the other angles. Well, 5x plus 1 would be 5 times 7 plus 1, which is 36. Well, if this is 36, we know it's been bisected, so this is 36. So this whole corner is 72. Well, we know that consecutive interior angles add up to 180 degrees. So if I take 180 and subtract 72, I get that that other angle is 108. And then each of them would be 54 because they've been bisected too. But I only asked for FED, so you didn't have to bisect it. You just needed that 108. And then 11. 11 is a square. As soon as I see that, I would go in and mark those things that are, you've always known about squares, right angles, and the sides congruent. Then remember the diagonals bisect the angles. That's one of the important things about that rhombus, which a square is a rhombus. So if they have been bisected, then I know that angle is 45, because 90 divided by 2 is 45. So to set this up, 7x plus 3 is equal to 45. So I subtract 3 from both sides. I get 7x is equal to 42, and x is equal to 6. I asked for x, and I have x. So there are a lot of qualities that we talked about today. Okay, these first ones go back to being a parallelogram, and all of these shapes are parallelograms. These next two are the qualities of being a rectangle, and then these next three are qualities of being a rhombus. Okay, and then what makes it be a square is, in particular, the 4 right angles with the 4 congruent sides. So it's a rhombus that has 4 right angles, and that's what makes it become a square. So you have to use all of those. We want to pay special attention to the diagonals are perpendicular and that the diagonals are congruent. It's the diagonals that really drive a lot of what we're going to do with these shapes. Okay, so keep this handy where you can see it all the time. And then when you get stuck, just start filling in anything that you know. And it may be extra information, but it might trigger